All right, so some of us missed out, and this is 04. Some of us missed out on the paperclip activity, which is fine, no worries there. But this is what we're going to be using based on that little portion in the notes that talked about the difference between element compound mixture, what an atom is, what a molecule is. So just really quick, atoms of each element. Atoms are the smallest amount, so basically it's how many circles did you draw? And now I have a legend or a key up at the top for what I want you to represent each type of substance as. So I'll do probably the first two or three of these just so that you can kind of see what I'm expecting here. So just wanted to kind of reiterate that. And remember, molecule is any group of atoms that are connected. Any group of atoms. So they have to be connected. In this case, for this first one, I like saying to not worry about that front one for now. That front one, and I would definitely write this somewhere, is how many of the following combination there are. All right, so that's what those big numbers in front mean. For the small numbers, like here, those subscripts, those are representing how many of that element are bonded or attached, they're connected in the combination. So the smaller one is the attachment. The bigger one is how many just total of those things are there. So what I like to do is I like to look at the combination first, right? So this is the combination, H2, which means that, and I'm going to use these circles that are hollow, H2 is an H that is also attached to another H, right? Two of them. So that's how I know that that is what an H2 looks like. And now I'm able to go over and use that big number in front to say, okay, well, I must have 4 of that exact combination here. You could write it whatever way you want. Doesn't have to be diagonal like that. And then we keep it going, right? Is this an element compound mixture? Well, an element is only one type of circle, right? A compound, based on our notes, is a combination, a bonding of 2 or more of those circles together. And then a mixture, of course, we know ends up happening with the physical combination of those things with a plus sign. So there's no mixture here, of course, because there's no plus sign. But I look and I see, are all the circles the same thing? And they are, right? They all represent just one particular element, which is hydrogen, which is why this is an element. How many what's the number of atoms of each element? Now, the way this is worded could be confusing at first. You'll get the hang of it. But when we look, we see that we have just hydrogen, which means that we just count up all of those individual circles, which is 1, 2, 3, 4, 5, 6, 7, 8. We have 8 atoms of each element. Since there's only one element here, it's just hydrogen. Total number of atoms would be the same then, and number of molecules. Now remember, it's any group. So here's what I'll do. I will circle the groups of things that are connected together, and I end up seeing that there are 4. So 4 molecules, and that's what differentiates a molecule from an atom. A molecule is a group of things that are attached. An atom is each individual portion, right? The smallest unit of measurement there. All right, so let's take a look at this one. N2, so I'm going to look and I see that N is that nice little like pinwheel. N2 means that I have two ends attached to each other, right? Plus 3O2. Now again, remember, to make it a little bit easier on yourself, just focus on the combination itself before you get into that, using that number out in front, that coefficient. In this case, it's O2. O is that nice little two-line bubble. And 2, O2, this one tells me that there's two connected to each other. That 3 out in front tells me that I have 3 of that combination. All right, and then in this case, look at this. We have a C that's touching an O2. So every time I see the plus sign, I have to write a separate substance, right? These are not all together. They're actually not chemically bonding to each other. They are strictly in the same space. So this right here is a completely separate thing compared to that O2 over here. So I'm going to draw that one out. Now the C's I have as the filled in circles. There's the C. And it is attached, we see here, it's touching. So it's attached to two O's. So we're just going to attach two O's to that, right? And there's no coefficient. There's no big number out in front of the CO2, which means that there's only one. All right, and there we go. Now, look at this. We have what I would say is a mixture of a bunch of different substances in the same space. So I have a mixture. Notice the pure substance, everything in the box is the same. A mixture, everything in the box is different in some capacity. Number of atoms of each element. So I have to look and see what elements I have. Well, I have N's, right? I have O's, and I have a C. So I'm going to just label out in that order that I said it, N, O, C. Right? So I just have to count up how many individual circles of each of those things I have in here. Well, I have two N's. I have 1, 2, 3, 4, 5, 6, 7, 8 O's, and I have one C. Right? And now that's going to be a total, right? Total number of 11 atoms. All right? And then I go to molecules. And remember, molecules are any group that are connected to each other. Well, there's a group that's connected here. There's 3 of these O2 groups that are connected. And there's that group there. That's a total of 5 packages, 5 groups. All right. So that is going to be, again, how we identify our molecules. For the last one that I'm going to do here, remember, look at the combination before you look at the big number in front. So the combination is N2O4. And those subscripts, remember, tell me how many are attached in the group with each other. Well, N2 means that there's 2 N's attached to each other. And that O4, since they are touching, right, we see that they're touching each other, must mean that those 4 O's are also a part of that. And now we can look at that big number out in front, and we see that how many of that combination do I have? I have 2. So I'm going to, for notability purposes, you would be able to duplicate, but because we're doing this on paper, it'd be easier for us to just draw it out a second time. There we go. 2 of those combinations. Now, I look, and I have to figure out element, compound, or mixture. Well, it can't be an element because there's more than one type of drawing in here, right? And I know that there's 2 capital letters, which means that there's more than one element. So it can't be an element. So let me write that here. Element, mixture, compound. Well, it can't be an element. Well, let's see about a mixture. Well, in a mixture, I have to have 1 plus signs over here in the formula, Or 2, I have to look in my box and see if if there's things inside my box that are different from one another. And in this case, they're not, right? Those are the same thing. So it cannot be a mixture. Well, it could and should be a compound. And why is that? Well, because we have N's that are attached to O's, right? There's 4 O's that are attached in each. There's 2 N's. N's and O's, they are different. 2 or more different that are attached to each other represents a compound. So this is a compound that we have 2 of. Each one has N's and O's. So if we add up all of the N's, we have 4. If we add up all of the O's, we have 8. And if we add those all together to get a total, we get 12. And then how many molecules or groups? Well, by now we should be pretty solid with this. There's one group, and there's the other. So there are 2 total molecules, 2 total groups or packages. So roll through this. Again, be careful with things like C over here. Now, this is not attached to anything, so it's just C by itself. And how many of those C's do you have? Well, that 3 in front tells me they're not connected. There's just that many of them, right? And notice, these are not groups. They're not groups, which means they're atoms. So these would not contribute to the molecule amount, right? So these are not molecules. They are atoms, right? Because they're just the smallest bit. They're just 1 circle each. So you can finish that one and finish the rest, and then we will go over this when I'm back.